Okay, so it's been a while since I've done one of these, making a video for when I'm gone, so I might have to adjust everything as I go, and let's just hope this works out. So we are working on chapter 7. Specifically, now we are getting into what we call factoring. And in the beginning part of the chapter, I said we're going from a problem to an answer, meaning we would have mainly a binomial times a binomial, and when we multiply that out, we got a trinomial. That's most of the problems we have. And yes, we did multiply a trinomial times a binomial. And then recently you did the monster boxes where you multiplied multiple term polynomials by multiple term polynomials. When you factor, this is the back half of the chapter, which means now we're going from the answer, which was the trinomial of what we normally saw, back down to the two binomials. So factor is what I call the F word in math. You'll understand why we call it the F word, but it's only the F word for math class. Don't take it anywhere else outside of the classroom. When you factor, you are rewriting a problem as a multiplication problem. So I'm going to define that. So here we go. When I write down on this board, you guys write down in your composition book, because I believe this is your first video of the year. I don't recall, but I think so. So here we go. 7.6, factor. And you're going to learn multiple ways of factoring. You're going to learn factor by GCMF. You're going to learn factor by what I call the ninja star. You're going to factor by grouping. You're going to factor completely. So you're going to see this title factor multiple times, but after it is the way that we're going to learn how to do it. Kind of like when I said you're going to learn 3 ways of graphing, and then after graphing, it would be the method. So here we go. 7.6, you're going to factor first by GCMF. Sounds a lot like GCF. Here we go. Let's define factor. Because there's a factor noun and there's a factor verb. So we are going to do the verb. Okay? So when you factor something, you are rewriting as a multiplication problem. That's really what happens when you factor something. Like when I say list the factors of 18, you're going to list 2 numbers that multiply to get to 18. So 1 and 18 would be factors of 18. So it's 1 times 18 to get 18. 2 times 9, 6 times 3. So you're just rewriting as a multiplication problem. Specifically this chapter, when we factor, you could have a binomial and a binomial. You could have a monomial with a binomial. You could have a monomial with a trinomial. So there's just a variety of different ways of when you factor, the 2 different factors will be. It's not always going to be the same thing. Okay? So we're just going to focus on today the verb of factor. Let me scoot that closer. Rewriting as a multiplication problem. Okay? And so GCMF, next one. Most books just say GCF, but I really like the GCMF because it really solidifies what you are factoring, and what that is the greatest common monomial factor. So it's a little bit more specific. Greatest common monomial factor. That's what it stands for. So it's just a vocab term, and when I throw the M in there, that as a reminder, a monomial is just one term. So it could be something as small as 5. It could be something like an x. It could be x squared. A GCMF could be as big as like 10x squared, y to the 3rd, z to the 4th, l to the 2nd, q. Something like that. But it's still just one term. So it could have coefficients. It could have multiple variables, or it could just be something as simple as a constant. So those are your 2 vocabs. What color are those supposed to be? You should know by now. But I will say they are pink. And so here we go. I'm going to do a couple different examples. And remember, tomorrow I will go over more problems in case you just need a little bit more help, because I'm not there today. So here we go. Factor. That's going to be the directions that you see, but specifically we're going to factor by GCMF today. So greatest common monomial factor. So here we go. I'm going to start out with something like, I'm kind of looking at problems. I'm looking at the book. I'm looking at the worksheet. I'm looking at a variety of things. So let's go 5z plus 45. So this is what I'd call the answer. Now I'm going back down to the problem. So you're going to write this as a multiplication problem. So you're going to, and what you're looking for is the greatest common factor, 5z and 45. So there's two things you always want to think about. What's the highest number that can go into 5 and 45? But then also when it comes to variables, there's another piece to that. But since both terms do not have the same variable, your greatest common factor will just be the number that goes into both 5 and 45, which is going to be 5. Now you're going to write that as a multiplication problem. So parentheses. And I'm going to say this a couple different ways. You're going to eventually like one way over another, but you're still going to hear both. So here's what I'm going to do. First way is I'm going to say 5z divided by 5 is z. But then the other way I could say that is 5 times what right here gets me 5z. And honestly, that is the one that most kids prefer is 5. And even though normally there's nothing written here, I would say 5 times what right here will get me 5z. And you can do the same thing with 45. So remember, it's a positive 45, so it wants to be a positive down here. So 5 times what right here gets me 45. And the other way I can say that is 45 divided by 5 gets me this, which is 9. And that's it. That would be the answer. So the work is part of the answer, which just seems kind of strange. And the way that you could double check this, I really like factoring by this method because it's easier and kind of quick to check that. So if you want to check to see if you factored it correctly, meaning you rewrote it as a multiplication problem, multiply this out. 5 times z is 5z. 5 times a positive 9 is positive 45. So that's how you know you got it correct. Let's do some more. Let's go. And so, however, in your notes, if you want to write side by side, that's fine. But when I do videos, because my board is so much smaller, I try and get as much on without having to erase it because I don't have the luxury of using my big boards from class. So, just want to explain that. So 2x squared plus 4x. I'm going to factor that. So this one's a little bit different because it's still two terms, but also both terms have a variable in it. I'm going to still start the same place. What's the highest number that can come out of 2 and 4, which is just the greatest common factor, which is 2. Write that as a multiplication problem. So it's always going to be, this is your greatest common monomial factor. I forgot to say that. Okay. This times right here gets me this problem. So here we go. 2 times what right here gets me 2x squared. A different way of saying that, 2x squared divided by 2. So if you do the division way, you're actually thinking about your exponent rules from chapter 6, I want to say. Okay. So 2 times what gets me 2x squared? X squared. And then same thing with 2 times what right here gets me a positive 4x. It's going to be a positive 2. So if you just put a 2 right there, you're like 2 times 2, that's 4. But we need a 4x. That means it's going to be an x. But if you notice, if you just pulled out a 2, these two still have a variable, which means you didn't actually pull out the greatest common monomial factor. So that's not quite it. When you factor by GCMF, you're taking out the highest number coefficient-wise and then the lowest variable. Here's what this looks like. So we know 2 is the greatest common, what I say, the biggest number, meaning the biggest number that comes out of 2 and 4. But then when you look at the variables, there's 2 x's here and there's 1 x here. And what's the most amount of x's that both terms share? And that's 1x. Because if you want to think about it this way, there's 1x in this toy box and there's 2 x's over here. And if you're grounded, let's say, your mom goes, I'm going to take away the same amount from you and your sibling. She can go in and take 1x from each toy box. And that way it's fair across the board. I don't know if that helps, but that's just kind of what I just thought of. So 2x, let's try it now. Because if I multiply this, I should not have a variable for both terms. So 2x squared divided by 2x is just x. The other way I can say that is 2x times x will get me 2x squared. And now 2x times what right here gets me a positive 4x plus 2. And let's see if I got this, because up here I didn't quite get it because I had the variables. So 2x times x, 2x squared. So that checks out. 2x times a positive 2 plus 4x. And you just factored. So on 2x squared plus 4x, your greatest common monomial factor is 2x. And it takes a little bit to get the hang of this. And actually, when we're done factoring, it seems like most kids want more practice on this because you don't do this as much as the other type of factor that we have for the rest of the chapter. So let's do some more. And right now, they're all binomials, but that doesn't mean that's the only thing you could do. Absolutely not. I can have 52 terms up here if I want it. And I am going to do a problem that's pretty big. So next one, 6x plus 2y. Remember, you're writing it as a product. You're writing it as a product of two factors. Rewriting it as a multiplication problem. Okay, so let's think about the numbers first. What's the highest number that can come out of 6 and 2? That's 2. Okay. Now, look at the variable part. Does 6x and 2y share a common variable? No, they don't. So 2 is going to be your greatest common factor. So 2 times what right here gets me 6x? That's 3x. And 2 times what right here gets me 2y? That's going to be a plus y. And double check it. Let's multiply it out. 2 times 3x is 6x. 2 times y is 2y. There we go. Sometimes they're pretty small. And let's see, I'm gonna start getting bigger. Let's go. I'm gonna still do another binomial, but I'm gonna start getting more exponents involved. So let's go 20y to the 4th plus 30y to the 2nd. So still 2 terms. I'm gonna do a lot of problems. So here we go. Greatest common factor of 20 and 30. So the highest number that can come out of both of those numbers, not 2, not 5. Hopefully you said 10. Okay. Now, look at the variable part. So if this has 4 y's and this has 2 y's, what's the most amount of y's I can take out of both? Which is 2. So remember, if they're toy boxes, your parents are coming in and taking the most out of this time 2 boxes. You're taking the most out. Okay. So here we go. 10y squared times what right here gets me 20y to the 4th. So let's start with the numbers. 10 times what gets me 20. That's 2. Y squared times what right here gets me y to the 4th. So knowing your exponent rules from chapter 6 will come in handy right here. But basically, here's 2 y's and 4 y's. How many more y's do I need right here? That's y to the 2nd. Do the same thing for this term. 10 times what gets me 30, which is a plus 3. Don't forget your signs. Sorry, I keep not showing you guys that. Y squared times what gets me y squared? If I put a y, that would have to be y to the 3rd, but I can't. So I don't have a variable right here. There it is. A way you could check it, double check by multiplying. 10 times 2 is 20. Y to the 2nd times y to the 2nd is y to the 4th. Remember, you're just adding exponents. And then 10 times 3 is 30. Y squared times technically 1 is y squared. And that's how you know you got it. Okay. I'm going to start getting bigger, so I'm going to erase all this. So hit pause if you don't have it all done. Okay. Remember, this is the problem that I showed you what happens if you don't pull out the greatest common monomial factors when you have variables in both. You did something wrong. Go back. Okay. So I'm keeping my vocab up there. Okay. I just have a lot of different examples. Let's go here. Let's go bigger. I'm going to start to do trinomials now. So 4w cubed minus 8w plus 12. So I'm still going to write it as a product of factors, which means something times something gets me that. Here we go. So we're going to factor this. What's the highest number that can come out of 4, 8, and 12? 2 works, but that's not the highest. That's not the greatest common monomial factor. Hopefully you said 4. And now you got to check the variables. I have 3 of them. I have 3 w's here. I have 1 w here, but I don't have any w's here. So that means I can't take a w out of each term. So my greatest common monomial factor for this problem is just 4. And now we're going to figure out what we multiply it by to get this guy. And I know I've been saying more multiplication, but it just seems like in the past, more kids prefer the multiplication way. But I'll stick to division right now. So 4w cubed divided by 4 is w cubed. And double check, multiply these two, you should get that term. Negative 8w divided by 4. So negative 8 divided by 4 is a negative 2. And w divided by 1 is a w. Positive 12 divided by 4 is a positive 3. An easy way of checking, I would check this factor right here. If there's no variables, then chances are I did pull out the greatest common factor. Doesn't mean it's always true. And of course, you could multiply it out just to check that you did it correct, but we did. Okay. Let's go. 50r squared plus, oh no, not 50, that's 5. Sorry, erase. 5r squared plus 20r plus 50. Yeah, plus 50. Let's just keep it that way. So kind of like the top one, except for this one has a degree of 3, this one has a degree of 2. Just looking at exponents. And then after this, we're going to start throwing in multiple variables. All right, here we go. Greatest common factor of 5, 20, and 50. Highest number that come out of all three of those numbers is going to be 5. It's weird talking to you guys this way because I don't have anyone responding to me. Kind of like I have to talk to myself here. Anyways, 5 times what gets me 5r squared? R squared. 5 times what gets me 20r? Plus, hopefully you said 4, but then if I said 5 times 4, that's 20, but I need my r. So it's going to be r right here. And 5 times what gets me 50? That's 10. Now double check. If all of these have a variable in here, then I didn't pull out the greatest common monomial factor. But since they don't all three have a variable, I'm good to go. But also, let's just multiply to be double, triple certain. 5 times r squared, checks. 5 times 4r, checks. 5 times 10, check. There you go. So when I call out my answers tomorrow, I'll say 5 times the quantity r squared plus 4r plus 10. That's why you really got to pay attention to your parentheses and know, because when I call out the answers, if you don't know what the parentheses are and how I say them, you're not gonna know if you got this correct or not. So pay attention to that. All right, now time for multiple variables. Here we go. Let's go, and I don't even have you guys ask about numbers. Let's go 3a to the third, b to the second, plus 18 a to the 5th, b to the 9th, minus 12, I don't know, a to the 4th, b to the, let's go 4th. There you go. Give you time to write that down. Kind of a big thing, but that's okay. Big polynomial, I said thing, but I don't know, the same thing. Okay, here we go. So greatest common monomial factor, remember, is the biggest number that can come out of 3, 18, and 12. 3. Okay, now, when it comes to multiple variables, I check to see that each term has the same variables. Does it? Yep. Yep, yep. Meaning they both have A and B. So now I know I can take an A out of all of them. But remember, you're taking the most amount of A's that each term has. So this term has 3 A's. Was that 2? No, that's 5. This one has 5 A's, and this one has 4 A's. So the greatest common monomial factor for your A is going to be your lowest exponent. Because there's 3 here, there's 5 there, and there's 4 there. So it's 3a to the cubed. Now do the same thing with b. Since there's a b in each term, I can take out at least 1. So you have 2 b's here, 9 b's there, and 4 b's there. So the most amount of b's I can take out is actually 2. I didn't mean to make this problem that way, but it's going to work out. It's pretty good. So, oh no, I just froze. Oh, great. Huh. Okay, second video, sorry.